Hello and welcome back everyone to Knowledge Connections 2020. I'm George Anatiotis and I'm your host here on the Innovators track, and we keep pushing through with more great talks. We're here today with Juan Sequeda and Bryon Jacob from data.world, who are here to talk to us about data catalogs and knowledge graphs and how these two are connected and how you can use knowledge graphs to power your data catalog. The floor is yours, Juan and Bryon. Take it away.
Great. Thank you very much, George, and we're excited to be here. So this talk, when we wanted to have a talk here, Bryon and I were thinking about something to be having a different, bold point of view, and that's the goal of this talk. So just a little bit about us. My name is Juan Sequeda. I'm the principal scientist at data.world. I've been in this knowledge graph space, which goes back to the original semantic web vision for almost 15 years. This is where I started doing my research, and I did my PhD at the University of Texas at Austin. We spun out our research into a company called Capsenta, which we did kind of pioneered a lot of the semantic graph virtualization on relational databases, developed Grapho, our visual collaborative real-time knowledge graph schema editor, and we sold the company. We're acquired by Bryon's company, data.world, and I've been part of kind of bridging the world between academic and industry, being on many standards committees, and now working on the property graph schema working group. And I'll pass it on to Bryon to introduce himself.
Great, thanks, Juan. As Juan said, I'm one of the co-founders, the CTO for data.world. I think maybe my story is a little bit similar, but inverted to Juan's. I grad school 20 years ago in AI machine learning, but really have spent the last 20 years, starting and working for a number of large companies, kind of more in mainstream data management. And the idea behind data.world was to really bring the power of semantic web and knowledge graph technology into that world. And so that's how I got connected up with Juan and ultimately acquired his company so that we can kind of work on this together. So.
And this is a side note I always tell people, Bryon at HomeAway, that was a company that acquired over 30 companies in 10 years. So if there's somebody who knows about data integration, it's Bryon Jacob. He has integrated over 30 different systems in just 10 years. That's people spend integrating 2 different systems in just 2 years. So to take that into account. So this is the kind of your typical example that you see, right? You have your sources, right? And you have your data producers, the personas like data engineers and data stewards. They have all this data from all these different sources. And the goal is to be able to integrate this data, to be able to provide it to your consumers of data, like your data analysts and your data scientists who want to be able to go answer your questions, right? And there's this big gap. And the typical marketing or architecture slides, it's that you put a knowledge graph here in the middle. But in reality, what you start seeing in here, there's very specific boxes, right? There's things like we need to do data governance. We need to have a business glossary, a data glossary. We need to have data virtualization and federation technology. We need to do data quality. We need to do data security, data preparation, data lineage, data, data, more data. Tomorrow, there's going to be more data things that we need to go do. And all these different aspects are needed to be able to go integrate data. So just simply kind of slapping on that, oh, a knowledge graph is going to solve us here. The devil's in the details. And there's a lot of details in here. And this is the big question, is how do you figure out what you need? Our position is that you want to start on 2 important pillars. The first is a pillar on metadata management. And the next is a pillar on data management. So you want to be able to build your strong foundation on top of metadata management and data management. And that is our definition of what a data catalog should be. Now, a data catalog you need to be able to go do things with quality and security and preparation and so forth. But depending on your use case, data quality may be more important than data lineage. Data preparation may be more important than data security. So that's why you don't need to really think about boiling the ocean and bringing all these things together. You want to start on these very important pillars and then bring in the other tools that you need. And how do you bring in these other tools? The knowledge graph is what really helps put this stuff in together. Because what we're going to go discuss here is that because everything is driven by connections and we can start connecting all these different systems together to ultimately be able to create your knowledge graph. So I've introduced two terms here, data catalog and the knowledge graph. A data catalog is a metadata and data management tool that helps users inventory and organize and access the data within their systems. And the knowledge graph, I know there are just so many different definitions and stuff, and this is what I call Juan's non-scientific, non-pedantic definition of a knowledge graph. You want to do data integration, where you're integrating internal and also external data sources. And second is that you want your real-world concepts and relationships to be first-class citizens, and those concepts end up being nodes in the graph, and the relationships end up being edges in the graph. And that's a simple definition of what a knowledge graph is. So with that, let me go pass it on to Bryon, because I want him to go tell us why your data catalog should be powered by a knowledge graph.
So I'm going to start by talking about the relationship in this direction. The data catalog is powered by your knowledge graph. So a graph data model is by definition flexible and agile. It's about entities and relationships, and it can be open world in the sense that you can bring in new entities and relationships, so that as you move across your organization, acquire new data sources, uncover new data sources, you can bring those into the model in a flexible way. Data quality, security, lineage, all of these kind of use cases of a metadata management system are represented in the knowledge graph as relationships between entities. And it's, you know, as with any application, it's not that you can't build this application on top of tabular, relational SQL databases. It's that when you think about the kind of expansiveness and the openness of this problem, by modeling it at where the entities and the relationships are first-class citizens, you end up putting the data, the actual meaning of what you're representing first, and you build a more flexible, usable, and powerful implementation to power discovery, search, recommendations across those data assets.
And one thing to add here, if you look at other companies like the Airbnbs of the world, right, that they've built their own data catalogs, guess what they built the catalog on? They built it on graphs.
Sure. So thinking about the use cases that we talked about for a data catalog, for a metadata management system, for when you think about, the first thing you want to think about is cataloging your data assets. What data assets do you exist, and how are they related to one another? This can be represented by, go back one slide, Juan. This represented by, thinking about those database tables and databases as nodes in the graph, and the relationship of containment as a relationship between them. Going forward to discovery, you want to understand what data assets are related to a topic. What physical assets, like this table, are related to what logical concepts, like the concept of order from my business glossary or from my taxonomy of my organization. You want to think about governance. You want to understand what agents and policies are related to those data assets. Again, here, so the simple example, Ruben is a person who is the steward of this database. Notice how each of these statements are a real world use case of something I'd like to understand, but ultimately they are represented by modeling the entities and the relationships as first class citizens, just like in any graph-based solution. Provenance. How are data assets related to one another and over time and in a derivation, in a state change representation manner? And collaboration. What people are related to all the data and analytical artifacts? If I want to understand all of the data, the data assets in my system, it's one thing to have kind of all the data represented in the catalog, but you also want to understand who are the other people who have additional information, who have actually, where is the prior art, and who else can I contact who has actually touched this data or has a relationship to this data? These are all concepts in the real world. Your databases, your reports, your policies and people, they're all real world concepts. They contain information about other real world concepts and relationships, but they themselves are concepts that have relationships to one another and the information they represent. Regardless of how you actually implement it, your data catalog is a knowledge graph. It's a graph of knowledge about these assets, and it should be the starting point for your enterprise knowledge graph that kind of speaks in the domain language of your business. So stepping through those use cases again, First I represent that this orders table is part of this particular database. I understand that that orders table is related logically to the concept of orders. I understand that Ruben is the steward of the sales database and that there's a net sales table derived from that orders table and a report derived from that, which was actually produced by Sally. All of these individual statements are things that are collected together by introspecting and understanding the metadata about these data assets. And these give you, when you bring them all together, a graph over which you can reason and analyze your data infrastructure to understand where the actual data and knowledge and information about your real world entities lives. So when you build this graph, ultimately you need a model that helps you make sense of this. Your nodes are going to represent concepts like data assets, databases, tables and columns, the agents, topics, etc. The edges are going to represent things like containment, things like logical relation, things like derivation for provenance and lineage. And so what you end up with is an ontology that describes this interconnected network of data assets, of the metadata about your data assets. What we have built internally is an ontology we call DWEC, but ultimately it is the majority of that is vocabulary from these open standards. It uses things like DCAT for the basic catalog structure, Dublin Core for basic metadata about digital assets, Pravo for lineage, SCOS for concepts, etc. This is the ontology that you start with to make sense of the data assets themselves, and it builds into the next section that Juan is going to talk about, where you actually then use that as the foundation to build your enterprise knowledge graph that's in the language of your business. And I'll just kind of close with, thinking about one specific use case and how this kind of really makes it real, makes it visceral. A common use case for a data catalog is to understand lineage for things like impact analysis. And when you do that, what you're really doing is saying, I want to go into the graph that represents all the ways that all of my data assets are interrelated, and I want to pull out a subgraph that looks at all of these things along the derived from dimension. I want to basically pull out all of the ways that things are derived from in a provenance sense, so that I look all the way off to the right here and say, I have these several Tableau reports, and I would like to understand where the data that powers these reports come from. That is a query against that graph that says, give me transitively everything from which these things are derived. This is just one quick example that I think is a common visual implementation in a cataloging and lineage solution to show you kind of how what you're doing is really querying across this graph database and pulling out an interesting subgraph to address a particular query. With that, I'll hand it back to Juan.
Great. So the point here is that your data catalog is about managing and understanding your metadata. And if you're going to do that, it ends up being a graph. So it ends up being a knowledge graph itself. But I know everybody here is really excited about knowledge graphs, and we're trying to learn about that. And our position is that your knowledge graph should be powered by a data catalog. So let's think about it. When within organizations, you don't know what data you have. This is the common problem everybody has, right? We don't know what data, we need to go search for data. So let's go catalog it. Let's go literally crawl and bring in all that metadata together. But when you do that, you want to be able to start connecting it together to understand how things are connected, everything that Bryon just mentioned. Once you start cataloging that data, you want to go find the data. The next thing is like, I want to go access that data. I found the data that I needed, right? Regardless, I talked to somebody, I figured out how things were connected. I now want to go access that data. Let it be, give me access to the raw data because it's being sent to me, or I want to be able to go query that data. And at this point is when you start realizing that I can go query it using data virtualization technology, data federation technology. I want to take a table in one database and a table in another database and go join them together, right? We want to be able to provide users with that quick and easy access to the data. But this continues to be what we call the application-centric view of the data, right? When we talk about real-world enterprise databases that you're cataloging databases that have hundreds, if not thousands of tables and thousands, if not 10,000 columns. And at this point, our position is that you want people to realize that their data is a mess, and you want them to kind of crash into the wall and realize, wait, my data, I don't understand this data. And what happens is that when you start cataloging the data, you start cataloging also the usage of the people. And you start realizing what are the most important data assets that people are querying. You can start cataloging also the queries that people are doing. And you realize, wow, people are querying for orders in all these 3-4 different ways. And when you start talking to people, you realize, wow, you use the word order and it means 3 different things to different people. So you start realizing these things once you start cataloging the data. And when you start cataloging the data and accessing the data as it is, people realize, I don't understand my data. And at that point is when they realize, I need to add my knowledge on top of that data. I don't want to go write these really complicated application-centric view queries to get what is an order. I would like to just have a concept called order and just access that data through that concept and get it. But I think a tendency that we see a lot is people want to jump into this knowledge aspect first. We call this the crawl, walk, and run. You want to be able to first crawl, catalog your data, walk, go access the data, understand how that data is today, and realize that there are a lot of pains that I understand it. And when you start cataloging the usage, you start realizing which are the aspects most important to people. And at that stage, you can go into the running phase, which is let's go add the knowledge to it and go create that knowledge graph. And by doing this crawl, walk, and run, it helps us focus on what people are actually using and needing, and that avoids boiling the ocean, because this is something that we have seen over and over again, that people want to jump in and create their knowledge graph, and they start building this big knowledge graph with having a clear view of success. So the crawl and walk is what we call the data catalog, and the knowledge graph aspect is when you're starting to go run, create that knowledge graph, and then actually using that knowledge graph. That's why we say the knowledge graph should be powered by your data catalog in order to be successful. So to give a little bit more of an example, when you're starting to go catalog, this is an example of a real world enterprise database, right? This is something that you can go catalog and understand how things are, what things exist in the real world, right? This is in your real world enterprise databases. But this is what if you give this to your data consumers, right? Your data scientists, your data analysts, your BI developers, they're going to scratch their head because they don't understand this. And that's why you go back and forth with your data producers to understand it. So you want to be able to go create your knowledge graph as adding that layer of knowledge, the layer of semantics. So imagine viewing the data this way. You see the real world business concepts, orders, customers, billing address, order lines, right? Customer purchases an order and so forth. You want to be able to go access this data. Access the data in terms of this knowledge graph view. But when you're creating that first catalog, you're starting to come up, for example, with the business glossary terms, and that helps you bootstrap what this is going to look like. Now, the big differentiation between having this kind of the knowledge graph view versus what we call the application-centric view is, if I have this particular question, right? What are the orders and their net sales in a given time period per their status? To answer that question, I would have to write one SQL query over that database, and it would be a very complicated SQL query, something that's much harder to maintain, something that a small amount of people can be able to understand because they need to understand the application database. But when you're starting to talk about what we call the knowledge and data-centric view of it, your queries, albeit I understand they're in Graph and Sparkle, that may be a new thing, but just think about that. The queries are now in terms of the knowledge view. It's a data-centric view of this. And everything now starts to have a complete lineage. So if you're asking what is an order, I have the connection of what that concept order is all the way back to the original application database. That's why you want to be able to start with the metadata first. So another aspect that I really want to push here is that we all think it's just a technology problem. It's not just a technology problem. That's the fallacy. It's about culture too. And I think this is the other aspect that we want you to take away. First of all, we talk about tools, but what about the people? Ask yourself, what does success look like? How do you know if you're going to build a knowledge graph, you're being successful? Who is responsible for the data? Assume that you generate data and the data is being used to run some machine learning models to go make a decision, and the decision that was made was a failure. Sales went down. Who is responsible for that? Or on the contrary, what if sales just increased dramatically because of the data that was generated? Who's responsible, gets promoted for that? And additionally, who does the actual knowledge work? Who understands what these concepts are and understands how they're supposed to be, what all the different meanings and how they're supposed to be connected to those physical databases? I think this is not a problem solved just by technology. This is understanding the people who are involved, understanding who is actually going to be consuming this data, and asking them what success looks like. Therefore, we need to be able to understand what are the business needs, the business problems, and tie everything that we're doing with the data to business value. Otherwise, we're defining success from a technical point of view. And I think this is one of the key problems. We have been in the same kind of rut in enterprise data management because we define success from a technical point of view and not from a social business point of view. Bringing the data into one place, into one lake, does not solve my problem. The problem is if the business users are able to go answer their questions. That's how we need to go define success. Who is responsible for the data? We treat software with the respect it deserves. It has a team. It has a manager, a product manager that communicates with the users of the software to get the requirements and translates those requirements to the engineers and defines tests. And we don't do that for data. We need to have this notion of a data product manager, and they're the ones who are managing the data sets that are coming out of that. And who does this knowledge work? We're all confused, and we say that the data scientists, right, are the ones who are supposed to do it, and they complain of the 80-20 rule, right? 80% of the data scientists spend their time cleaning the data, and then only 20% of the time they do the analysis, and that's true. But now we treat this 80% almost with disrespect. We say it's a data janitorial work when it's the crucial knowledge work, that knowledge of what things mean in our company. So this needs to be we need to separate it and make it into its own role, and what we're calling the knowledge scientist. Now, people work together, and the question is, how do they work together? What are the processes that people need to go to? How do you avoid boiling the ocean? We don't want to have the old school waterfall approach. Yeah, how do people work together, right? We need to have agile methodologies, what we're calling agile data governance. And one of the things I always tell people is like, why do we have brakes in a car? And the immediate response usually is so we can go slow. It's like, but no, we have brakes in a car so we can drive fast safely. And that's the mentality that we need to go think about when we're thinking about data. And how do people work together? The data product manager needs to set up sprints. We need to think about how to document data. We would never dare release code into a master branch without any comments. Why do we do that for data? We don't document it. We don't document how it's being transformed, the transformations, the queries. We don't do that. We would never dare right now to go release code without anybody code reviewing it. Right? We do pull requests. People go review our codes, right? We even do pair programming. Why don't we do that for data? These are the social aspects that we need to go consider. So to take away, frankly, I think it's just time to transform enterprise data integration. The way we have been integrating data has been the same. So your data catalog powered by a knowledge graph. Your first knowledge graph should be of your metadata, of your tables and columns. Why? Because you need to know what data you have. And by know means you need to have a knowledge. That's what we're talking about. The knowledge graph of your first knowledge graph should be of your metadata. And then your knowledge graph should be powered by the data catalog. To build your enterprise knowledge graph, it needs to be done to solve business pain points. And I know people are going to be so tempted to jump and start creating their knowledge graph. Please don't do that. Why not? Because you are basically diving into the deep end and you will most probably drown, meaning you're probably going to fail. And what's going to happen is that when people start looking at this knowledge graph, they're going to ask, where does this data come from? How do I know I can trust it? And the answer to that, it's the metadata. So that's why you should start with the data catalog as a strong foundation of metadata. Crawl and walk first in order to succeed with your knowledge graph to run. And I know Bryon has some final words here.
No, I think just as you said, your data catalog is a knowledge graph. That knowledge graph is actually going to be a fundamental and critical part of your enterprise knowledge graph. The knowledge in your knowledge graph isn't knowledge if you can't kind of state where it comes from. And that is exactly what having a model of your data assets, the metadata about your data, your policies, your organization, and how it all hangs together. It is the foundation of your knowledge graph, and it is fundamentally an integral part of having a real and powerful knowledge graph for your enterprise.
And one final point is, we have to be very honest. We're people who are here who are attending this conference. We're all very excited, but even though we see Gartner and we see where they're putting knowledge graphs and all that stuff, this is frankly still very early, right? Companies are not knocking on their door on saying, I want a knowledge graph. They do not have a budget item, the budget line item that says, go buy a knowledge graph. They're not there yet. So knowledge graph is still new in the industry. There needs a lot of education for it. So we believe that a way to get knowledge graph in is to focus on a data catalog powered by a knowledge graph to sneak in the knowledge graph within an organization. The value of a data catalog is evident right now to the business, right? There's magic quadrants for data catalogs, right? There is a line item to go buy a data catalog. The market is asking for a data catalog now. So if you want to help the knowledge graph industry grow, start with the data catalog powered by a knowledge graph. And with that, thank you very much. I think, George, you're on to moderate questions.
Yep, yeah. And actually, you've been quite active in responding while you were giving the talk, which is pretty unusual, but also a little bit unfair if I compare to the other people who gave talks, because there's two of you. So well done. And I see you also started the conversation with Dean Alamank in the comments, which I've been following with great interest. And so I'll just relay Dean's latest comment, basically. So he's saying, for the benefit of the rest of the people who may not have the chance to follow the conversation. So he's asking, how do Juan's comments about data governance relate to the fact that we'd like to reuse data from outside an organization? We don't know if the external data has undergone the governance that he talks about. Does that mean that we can't use it? And he hopes not. And it's a long comment, and it includes a number of questions, actually. And then he concludes by asking, how do we reconcile the need to manage data in the way Juan is talking about with a desire to use external data?
Yeah, I mean, I can jump in on that. That's what I think it's a great question, and I think the answer is you can represent that external data as concepts and entities. You can represent what governance has taken place if you know about it externally, and what governance may have taken place on that internally, right? So folks, something we get asked a lot is like, how do you deal with data quality? How do you kind of know that only quality data is within the catalog? And the answer is, well, we don't, but we do, in the sense that data quality isn't an absolute thing, right? It's always kind of use case and need dependent. So what you can do is you can represent facts about data, what assessments have been made, what ascertainments have been made about this data, and then within a particular context, you can assert policies, which are what ascertainments need to have been made about this data in order for it to be useful for this use case. And so the same piece of data might be completely usable for some kinds of research purposes within your organization, and might be totally unusable if you're putting together, your SEC filings, because it hasn't gone through proper vetting. That's not two different pieces of data. It's not two different. It is two different ascertainments of quality for different purposes, and third-party data is absolutely part of your catalog. You just need to understand, where did this data come from, and what governance has been. I would say though, like, if to kind of like back to the framing of the question, if you just bring in a catalog of here's a bunch of open data that we haven't really looked at or scrutinized or made any ascertainments about, you probably shouldn't use that for most critical use cases, because you don't actually know anything about the quality. So you have to really kind of have what factual quality ascertainments have been made, and how does that relate to the policies of use that I have.
So a couple of things I want to add. One is you first need to go catalog your own stuff to go know what I have before you want to go bring other things. Otherwise, you're just like throwing stuff in the wall and see what sticks. Second, this should be use case driven, right? Why are you going to bring in this other data? What is the problem that you're going to try to solve with that? So I think that's how you want to be able to go understand that. And then once you realize that I have this particular use case, this is the problem I'm going to go solve, you're going to bring in that external data inside, and then you're going to have to add the governance to it and figure out, well, can I actually use this or not, right? We're so kind of entrenched now with these magic wands of AI and stuff. It's like you put people in the room, they won't even agree. Why the heck do we believe that AI is going to come up with the right answer when the humans won't even agree? We need to stop thinking about that. We need to kind of really put our feet on the ground on that aspect. Now, I think the way the market is going to evolve, and this is much bigger than knowledge graphs, is the data marketplace. A data marketplace is going to be a data catalog of your internal and your external data. And you're going to see, and so you have data catalogs for folks to go use it internally in their enterprise. And we're going to start seeing data catalogs of open data that are really starting to add that governance. And guess what? I think the winners are the data catalogs that are going to be able to do both. So take a look and watch out for data.world for sure. And I think I'm looking at one of the chats there from Janine Hill asking about somebody was asking about the ontology that we were talking about. Frankly, the ontology we have is out there, right? It's DCAD, it's DC, it's all that stuff. We internally have taken all that stuff and added some glue together, right? We need to go connect that stuff. And I think part of our plan is we're cleaning it all up and we just want to go release it. So we will be open sourcing the data.world enterprise catalog, but note that it's all open standards plus a bunch of glue that we just added to that. So I think that's something valuable that the industry needs.
Well, we
don't have a paper that discusses the glue, but we probably should. That'd be a good thing for us to do and prepare a presentation on.
I am working on that. We'll have that published soon.
Yeah.
Okay. So thanks to both of you. So thanks once more, and we're wrapping up, and see you in a bit.